the battery world. A few companies like Donut has come up with a solid state battery. So there's been a little bit of controversy with that if the battery technology is actually real or they're skewing the numbers or if it's just hype. But they're not the only ones. There's a few companies out there right now that are actively working in the solid state batteries, kind of the holy grail, I guess you could say, of battery technology to get rid of the actual electrolyte and go basically completely solid state. So, yeah, what else we got on the table? The weather here has been horrible. Like minus 30 wind chill in Toronto tonight. It's just crazy, crazy cold. And we have a storm coming in on Sunday, and that's supposed to bring us about 10 inches of snow. So, yeah, it's the last couple of weeks have just been brutal, to say the least. But hopefully, we'll be able to warm things up tonight. Again, for the third time, we have Dr. Weiping joining us from Florida, and he's a senior NASA engineer. He's worked with SpaceX and Blue Origin. Is that correct?
Yes, also.
Yeah. So he's going to join us. He's, I guess, innovator when it comes to electromagnetics. That's kind of his passion. And he's going to share some stuff with us tonight and educate us on his theory. And we have Philip on. We got all the invites out. Hopefully Lulu's going to join us soon. And Bernie's going to join us as well. He's in California with Nathan. And he spent the day at the beach today. So he's going to talk about that. Enjoying all the California sun. While we're
I'm going to join in pretty soon in San Diego.
Yeah, that'll be nice. You'll have to invite me down there, Philip.
Yeah. You're welcome. You guys are welcome anytime.
You are invited to Florida, so I can take you. To,
you know what? I've never been to Florida yet.
Okay.
New York.
So
I've been to California. I've been to San Francisco. Where else? But I've never been to Florida.
Well, the weather is beautiful now.
I'm jealous.
I've been to the Disneyland World in Florida. Disney World, sorry.
Yes.
In Florida when I was a kid, 2 times, but it was nice.
Yes, that's the biggest, Disney World, the biggest one, at least in the United States, right? Yeah.
Yeah. I remember the Epcot Center was my favorite.
Epcot Center. Yeah, I remember they used to advertise that all the time.
Yeah.
But my parents never took me. I kind of resent that.
So now you are already parents to your kids, right?
That's right. Yeah.
Are you doing better parenting than you?
We do. Well, they do a lot of traveling. Like we've been to California and New York, and my wife's Filipino, so they go to the Philippines every couple of years. So
Chinese, Asian culture.
So I've been to South Korea, Philippines. I didn't really spend much time in South Korea. It was more or less doing a transfer with the airplane, but so I've been around too. Not as much as my wife has, but we've done we do a lot of camping in the summer. Last year we went to Calgary for a week. That was really, really good. Went into Banff and everything. So we had a lot of fun. Yeah, excellent trip out to Calgary.
Can your wife speak some Chinese?
I don't know. I'll have to ask her. I know.
Okay.
Well, she speaks Visaya, which is the southern dialect down there.
Okay.
A little bit of broken Tagalog. But and she speaks English too, no problem. So.
Yeah. Me, I don't speak well different languages, but I do kung fu, so I can act well. You know what I mean? I can my muscle memory works well. Not my brain memory. It doesn't work well, but my muscle memory works well.
Your brain memory.
That's a
Yeah,
talent.
I'm black belt, and I did kung fu as well, Wing Chun kung fu. So
You are martial arts art, right?
yeah.
Yeah, he's a black belt. Yeah.
Oh, no kidding!
Yeah.
Wow.
Black belt in Taekwondo, and I'm a former North American finalist in Taekwondo.
No kidding. North America
Yeah,
finalist. You mean competing
yeah,
in the United States too?
yeah. I mean, Americans came to Canada, and I kicked them all. And I was just 18, so I was the youngest in the adult division, and I beat everybody.
Yeah, that's cool. Yeah, it's good. I did a fair amount of judo. I did judo for about 4 or 5 years when I was younger, but I wish I stayed with it. I didn't. I don't know. I just got out of it, but I enjoyed the judo. It was really good exercise. Yeah. So
Yeah.
I guess
Ooh.
Philip, you can kind of give us an update. What's been going on with you in the last week?
Well, a lot of stuff. I started the DARPA drone lift challenge with Dr. Ricken
All
and
right.
many associates. So I started doing calculations for that to simulate. I don't have the hardware yet, but I need to simulate the drone. The drone trajectory
Right.
and the all the effects. I can't mention them, but all the mathematics required to drive a drone to win the
Right.
challenge and optimize
Oh,
the speed mathematically.
I was wondering, did you see the headline this week about this company? I forget the name of it offhand. It starts with an F. They made this thing where it's like a pad. It sits on the ground, and if you got a drone flying, the drone doesn't have a battery in it, or sorry, it has a battery in it, but it will send a microwave energy to the drone while it's flying and
Yeah,
charge it while it's flying,
yeah, I saw that. Yeah,
in-flight charging. So all they
yeah,
have to do is focus this, mirror or whatever it is, the antenna at the drone, and the drone will actually charge its battery while it's flying.
Oh, okay.
yeah. There's energy beaming is very popular these days. Finland is able to beam energy as well. Japan,
Right. Yeah.
Caltech.
Finland. Yeah.
Yeah,
Yeah. Yeah. So that's kind of interesting technology, being able to beam the energy to the craft while it's flying and
Wow.
charge its
yeah,
batteries
Wow.
yeah.
That's a
while
new.
it's
Yeah,
flying.
that's interesting.
I
There's some recharging drone is on the high power cable in
Oh,
the
okay.
sky. Is that have you heard of this one thing?
Not the what cable in the air, but they have like an antenna at the ground level, and it
Oh, ground level the one.
yeah, at ground level, and it just points at the drone, and then the
Oh,
drone starts charging.
oh. I watched the video. They said they landed the drone. Basically, is on the high powered
Mhm.
the cable line, and charging them, and then they fly away. So
Right,
that
right.
could be another way to
Yeah,
charge.
interesting
it,
concept.
it's
Right.
funny because in 2023 when I presented my theory in National Harbor, um, close to Washington D.C., I presented my theory and I had this idea of teleporting energy by converting high frequency electromagnetic waves of low density into low density, low frequency electromagnetic waves, but of high density back and forth. So you could teleport energy. And at the same time, DARPA had launched the energy beaming project.
Ah,
So since 2023, it's kind of people woke up and it's
yeah,
become uh, the trend, since the last 2 years.
teleporting energy. Yeah, would that be like almost like a scalar effect?
yeah, like I was saying, it's converting the high frequency of low density into
Right.
low frequency of high density. So
Right.
your low frequency, you can travel through walls. You know what I mean? Like radio
Right.
wave.
Yeah.
So
Travel
the
through any
waves can
medium.
travel through walls, and then you convert them back and forth
Now,
into.
how about distance as far as teleporting?
Yeah, so the low frequency waves can travel longer distance.
Right.
They can travel longer distances because they won't they travel through matter. You know what I mean?
Right.
Radio
I think
waves, they
that's
have a
really
longer
important.
reach.
Yeah.
Yeah.
That would be very useful, for space travel, because you're dealing with such a larger scale and distance between each
Yeah.
other. So, like they were saying, at some point, if we get the scalar technology done properly, those robots that are on Mars right now, instead of taking 7 to 8 minutes for a signal from Earth to Mars, that could be reduced to like almost instantaneous.
Yeah.
So if that's possible, then that will really open up space travel, because you have to communicate,
Yeah.
vast,
And
vast distances.
according to my theory, I can't go into all the details, the details, because I got some technology I keep trade secret, like antimatter and force fields. I keep it trade secret, but um, the speed of light is not a cosmic cost. It's not a.
Constant. It's an
It's,
arbitrary
it's,
constant.
yeah, it's
Not
not a
really.
constant. It can be changed if you change. If you change, like the neutrino, you remember somebody sent me an article about the mass.
Oh, yeah.
Degen from APEC. He sent me an article saying that the neutrino was changing mass when it was traveling. But if it changes speed as well, because the mass is energy, so the way I understand it is you can convert the energy into speed and speed into energy. The kinetic energy is going to be the same, but you can have an equilibrium between the two, the
Right.
speed and energy. So it may lose mass, but the speed is gonna increase. You know what I mean?
Right. Yeah,
It's
because
really
like
it's really
I think that's where like modern day science, we need to do a little catch up as far as using its speed of light as like a benchmark to go for, because the speed of light is not always a consistent 186,000 miles per second. It varies. There's a plus minus to that speed. So, do we actually use speed of light as a benchmark? A figure to use in calculating stuff? I don't know, like 1% or even 5%, that could be a huge margin difference between, right?
yeah
So, can we really use the speed of light as a unit?
yeah
I don't
and
think so. I personally don't
I
think it
doubt
can
it.
be.
Yeah, there's
uh,
some
uh, uh,
physicists, mentioned, the speed of light measurement never accurate actually.
Yeah, it's
yeah.
never accurate. Yeah. And there's a lot
Also,
of people that agree with us on that. Like Eric Dollard, he's probably one of the best electrical engineers I know of today, that knows Nikola Tesla's work, has actually replicated every experiment that he did to a T. He pretty much says speed of light is an arbitrary constant. It just you can't use it. It varies.
yeah.
It's too much variation.
If
But
you cannot even measure accurately, how can you use that benchmark, right?
That's right. Exactly. Yep. Yep.
Yeah. So for,
Mainstream physics is a portrait like everything is in scale. Some things is exact fact, but in practice,
like
many things
well,
are.
you know what? The other thing too is what the universities across the world have been teaching how to stay within this framework that science has created. But, over 100 years have passed in technology since, Tesla and all, Heaviside and all those guys, that, we've made some progress in the last 120 years. Some of our texts should be updated. They need revision.
Lots of it. Yeah.
Yeah, and I'm not gonna go into details again, but for me, the antimatter creation, it's very easy to achieve, and I can give some hints, but based on the annihilation and the pair creation, we can achieve antimatter genesis pretty easily. And the speed of a photon, the little correction here, Einstein was saying a photon doesn't have mass, but energy is mass. So if a photon has energy, then a photon has mass. You know what I mean? It has an equivalent mass. So these are little corrections that means a lot. That explains a lot. I did all the mathematics to correct Einstein for that, and it's all in my paper. And also the speed. Again, the quantum tunneling effect is similar to the variable neutrino speed that I was talking about earlier. It's just the energy of the particle is converted into speed or kinetic energy. The speed square in the kinetic energy equation is just temporarily changed into. It just has a boost of speed because the energy, the energy kind of there's energy destruction. There's energy
Some entropy.
destructive interference that puts the frequency at zero. While the energy is at zero, the energy is converted into speed, and for me, that's what quantum tunneling is.
Yeah.
It's
I'm wondering some of the battery technology that I've been working with, where especially in the solid state battery. So you have a differential between the anode and cathode. So you have charged electrons coming off your sacrificial cathode, sacrificial cathode, and those ions have energy, and they're transporting through a median where really there's nothing there to push them, or you would think, but they're finding their way across the solid state median to the other side. It's its own energy. So I think there's some similarities. I could be wrong on this, but I have a feeling there is some sort of quantum tunneling happening in these solid state batteries.
Oh yeah.
Because you have the charged electrons coming off. They have charge. They're charged. They have a magnetic field around them. And somehow they're making it through this median where really there's no way for them to actually do it, but they're doing it. They're making their way across, right?
But it's
So
possible
I don't know. I could be crazy.
no, but it's possible there's destructive interference. When there's destructive interference, the energy is converted into speed, and we can test that with the double slit experiment. There's destructive interference, but we never tested if the speed of the dark photons were increased. Because the energy needs to be converted into something. If it loses,
how about gravity density? This is Stefan, one of our listeners. Gravity density differential.
Yeah, that's exactly what a force is. And it's proportional to the time dilation as well. So you have the energy density differential. That's exactly what a force is, and because of the differential in time dilation, so you have point A and point B that have a different time dilation. That's going to create an acceleration or a force. So it's very simple. It's all mathematics.
Interesting. Hi, Lulu.
Hey, Lulu.
Hi, everyone. Sorry.
I can tell.
Hat on. Is it
I
still
can tell.
in Texas?
Well, I'm mentally getting ready. You know, we're gonna hit freezing. So I was late actually preparing. I went and got some supplies in case there's a lockdown or the power goes out. Yeah.
Yeah, you don't get.
I'm going to San Diego in 2 weeks. By the way, Lulu.
Very good job. Good job.
Yeah. So if you guys come over in California, well, we can meet me, Nathan, and BurnEye easily. You can meet and Dr. Yu in Florida, so you can meet everybody except Mike.
Visit Florida.
Yeah, you can meet everybody except Mike. He stays here at -30.
Yeah. Well, I have a day job, right? So I kind of have to keep food on the table and stuff.
I can work remotely, so.
What is the time range that you're going to be in San Diego?
In 2 weeks, before the Super Bowl.
Okay, but how long are you going to stay there?
It's until May or June because I need to move out of my apartment here in Montreal.
Okay, so I have time.
My stuff out.
Okay, good. Then I have time. It's not a limited window. So, because I also have kids. I can't just pick up and go. They've got schools. I gotta pick up and drive, and So.
How old are they? Can they? Didn't you say that they can handle themselves for a couple of days?
For a few days, yeah, but more than that, yeah, they don't, because they don't drive. They're kids.
Okay.
They need somebody to drive. Bring them things and stuff. So yeah.
Get them food.
Yeah, I mean.
Yeah. So
I need to go.
Doctor, are you ready to
yes
into your presentation here?
Yeah, you go ahead.
I'm gonna post this video here. Let's see. Oh, we got BurnEye here.
It's so dark. Hello.
I'm just riding the bus. I will be joining in from a car very shortly.
Okay.
Love you guys. Sorry, Dr. Weiping. Good to see you. I'll be listening. We'll see you guys in a little bit.
Okay, sure.
All right. Just bear with me here 1 second. I'm gonna get doctors.
It's fun. I don't have to do the thinking tonight. Dr. Yu is gonna present his theory.
So you guys gonna be peer review me, okay?
Yeah.
And just say, want to say something? Just say it. I want to explain everything. If not clear, that means I'm fake. Okay.
Yeah.
I wanted to explain until you understand. So.
All right, I'm going to share my screen here, and then we're going to play this little video that Dr.
I'm gonna grab some paper.
Yeah. Okay. Can you guys see the screen? Okay.
Yes.
Yeah.
Yeah. Okay.
Can you zoom it in?
Physicist and manager of crew vehicle subsystems at the Kennedy Space Center, has made groundbreaking claims that challenge the foundations of modern physics. He claims that everything we've been taught about the universe, from the structure of the atom to the nature of particles and energy, is based on faulty assumptions dating back to the late 19th century. These findings could radically change our understanding of space, technology, and even unexplained phenomena such as unidentified flying objects. Dr. Wank emphasizes 3 key principles that he believes will unlock a true understanding of the universe. Monocharged particles do not exist. Electrons, protons, and
Sorry.
Dr. Wank, a NASA physicist and manager of crew vehicle subsystems at the Kennedy Space Center, has made groundbreaking claims that challenge the foundations of modern physics. He claims that everything we've been taught about the universe, from the structure of the atom to the nature of particles and energy, is based on faulty assumptions dating back to the late 19th century. These findings could radically change our understanding of space, technology, and even unexplained phenomena such as unidentified flying objects. Dr. Wank emphasizes 3 key principles that he believes will unlock a true understanding of the universe. Monocharged particles do not exist. Electrons, protons, and other particles with a single charge are impossible according to Coulomb's law. 1785. If you try to split a negatively charged particle, you get 2 negative ones, which repel each other and cannot exist stably. This disproves the classical model of the atom with orbiting electrons, quantum mechanics with bouncing particles, and the idea of a perpetual motion machine, PPCH motion, in atoms. Photons, as particles of light, don't exist. Light isn't a stream of particles, but electromagnetic waves in a magnetic medium called the ether. All energies, including chemical and nuclear energies, originate from magnetism. The only fundamental particles are magnetic dipoles. The universe consists only of tiny magnets with north and south poles. This simplifies everything. Gravity acts through a magnetic medium, not an empty space. These errors, according to Dr. Weiping, originate from Joseph John Thomson's 1897 experiment with cathode rays, which was incorrectly interpreted as evidence of the existence of negative electrons. Since then, physics has gone down the wrong path, generating complex theories like string theory that attempt to correct non-existent problems. Particular attention is paid to anti-gravity technologies. They are already real and based on magnetism. Rotating systems, like gyroscopes, create stability and allow for enormous accelerations of up to 600 grams without structural failure, since the force acts uniformly, as in free fall. Spherical unidentified flying objects with lights, according to eyewitnesses, could be just such devices. Rotation creates plasmoids and magnetic fields for lift. Dr. Wank commented on the recent 3ATC object approaching Earth. Its closest approach was on December 19. NASA officially does not consider it an alien craft. It is a natural object with comet-like characteristics, generating tails under the influence of solar magnetic fields. Biological creatures are unlikely to survive interstellar travel, but robots or plasmoid forms are possible. The mystery of the disappearance of MA Airlines flight MH370 was also discussed. Analysis of video and data convinces the expert that the plane could have fallen victim to a directed electromagnetic weapon. Plasmoids, similar to lasers but in the invisible spectrum, infrared, or ultraviolet. Such systems are capable of burning objects with concentrated vibrations. As for NASA, the agency's colleagues are open to the idea of extraterrestrial life due to the vastness of the universe, but officially focus on human spaceflight. Delays in returning to the moon are explained not by secret bases, but by budget cuts from 3% of GDP during the Apollo program to 0.1% today. This is due to the loss of knowledge and the need for new materials. These discoveries promise a revolution in technology. Electromagnetic propulsion systems will reduce fuel consumption by 98%, making space travel accessible. The universe is simpler than we were told, emphasizes Dr. Weiping. Rethinking the fundamentals of physics will open the door to infinite energy and new horizons. Experts call for independent verification of these ideas and open discussion. The question remains, how quickly is the scientific community willing to acknowledge century-old mistakes and move to a new paradigm? Dr. Wank, a NASA physicist.
Okay. All right.
Thank you for the introduction.
Yep.
So,
Awesome.
okay. I think we have the tremendous, audience, the best one. So I want you to be my peers and examine every statement I said. Okay. So,
Yeah.
okay. I know we have a theoretical physicist here. Okay. So I hope you can see my screen. So today's talk is about unlocking the mystery of the universe. Actually, it's very simple. And I will tell you, first of all, I'll tell you what's the trigger event for me to interest in physics and to keep studying this one. One reason is when I was in middle school year, the first thing when I take a physics class, the first thing I doubted, the first thing I doubted about physics, actually, starting with the electricity model. I was lost. Could never conceive how could a solid cable wire and with a solid particle electron travel in about 60 or 70% of the speed of light. I could never conceive that concept. So that's why I thought something must be wrong with our model of electricity. And turns out I'm right. Okay. And then the second thing is about atomic model. I could never imagine. So atom itself is a perpetual motion machine. We have an electron, negative charged electron, constantly revolving from very tiny nucleus at a fraction of a percentage of the speed of light, constantly, which means every single matter made by atoms, right? Every single atom It's a perpetual motion machine. So where comes the energy? What keep them constantly running without the radiation or loss of energy, right? At that point, I already made up in my mind. I said this model, this is called the atomic orbital model, must be wrong. However, I waited for dozens of years, after I got my PhD and started working for NASA. Still nobody tell me these are wrong. So I said, okay, let's put it in my own hands. Okay, so this is my trigger event. I when I talk about this one, many people, they said that they also had this problem. Say why the electron, why a Coulomb's law, seems like has identical form as a Newton's gravity law. They said something's must related, which I firmly believe these two things must related. But but physics books, even in my PhD year, no physics book think about that they are related because the huge magnitude difference, right? And eventually I find out, okay, actually explanation is very simple. Okay, so much about the physical, the trigger event. So now I'm talking about the fundamental problems with physics. I summarized here in one chart. So this is a conclusion of my study, okay? So, and we can discuss those things afterwards. So basically say 3 key points to unlocking the mystery of universe. 3 key points. The first one called the monocharged particle. The monocharge I referred to single charged. Say electron is a single negative charge particle, or positron, or proton, or quarks. They have a positive charged particle or fractional charged particle, right? I all consider these are called a monocharged particle, or simply say all the elementary particles, discussed in the quantum mechanics called standard model of physics. If you look at the conclusion is none of these particles exist. So I hope you understand that the gravity is what I just say. All these called the monocharged particle and neutral particle defined in quantum mechanics. None of these particles can exist in this real world. It's all fake. So that's why by end of today's talk, you will know entire quantum mechanics is founded on fatal law, on the wrong foundation, and it cannot be cured. It has to be discarded. Okay, so then people say, hey, if you say all these say charged or non-charged particle, and also include the second part, so that's a false carrier, photons, or WZ bosons, those so-called false carrier. This concept is so ridiculous. Somehow, force has to have a particle as a carrier. That's so ridiculous. But however, and I discovered those particles non-exist at all. So then people say, hey, if you say all those particles, basically defined by standard model physics, does not exist. So why are we living in the real universe? So what really particles really exist? And I will convince you before end of the day, say only one and only particle can exist in this universe, and that particle made up the entire universe, entire matter, force, field, and energy. So everything made just by one single particle. If you look at I'm not sure if this there has a Faraday research bar, block the part of the screen. So that is the magnetic particle. That's the fundamental particle. It's called a magnetic particle. This is the only particle can exist. So I just made this huge claim, okay? And then next, I'm gonna demonstrate, give you evidence, say why I believe this particle cannot fundamentally exist. And I'm gonna listen to your critic, okay? Okay, so now, I'm gonna do this demonstration. I assuming this black ball in my hand represent electron, and this orange ball represent say positron. Okay, or you can say proton. Okay. So now what I'm trying to do is the single charged electron cannot exist in this universe. So what's my argument? I hope you guys tell me if my argument is correct. Okay, so let's assuming the current monocharged electron, so single negative charged electron, let's assume it's true. And then let's say, if assuming it's true, and when based on the physical principle, if this assumption result in contradictions, okay? So assuming this is a negative charged electron, so what happens if I hypothetically split the electron in small fragments? So in this case, I just split them as equal halves. So can anybody tell me, Phil, you are expert in gravity theory, right? Can you tell me, so if I split a negative charged electron to two halves, so what kind of charge it will be carried by these two halves?
Well, you would think if it's split, you have one positive and one negative, right? Because hypothetically split, okay?
Right. And so, you said, Mike, very creative, okay? You said one positive, one negative, okay?
Right.
Phil, is that possible?
Well, an electron is a point particle.
Right.
So you can't split it.
See, that's the exact fallacy we were taught by mainstream physics. Somehow, electron is the smallest. Electron has a mass, right? Has a size. Somehow, we were told the electron something cannot split. That's completely the fantasy. Okay, so in this real world, we don't need to physical split. We just say, hey, electron has a charge, right? Can you, if you hypothetically divide it by half, hypothetically, you don't have to real physically to do it. It's too small, right? So what do you get?
Well, you get two half negative.
Okay,
particle.
so we got two different answers.
Well, I'm thinking you have a photon emission out of it, so you're like when it breaks apart, something is gonna energy is gonna be expelled out of it.
You need the energy, right? Okay, so you know what I'm talking about is a fundamental particle. We told electron is a fundamental particle, so it's not a process. So electron cannot say, hey, I absorb a photon, or I emit a photon. If electron can emit a photon, what happens? Electron will be not elementary particle. Elementary means basic simplest structure and carry single charge. So photon, I will explain to you. So photon is emergent property. Okay. So so I will. So now I basically got two answers. One is split a negative charge, get a one half positive, one half negative. And I, from a few, said you can only get a two negative charge. Let me first explain why one positive, one negative is not going to be physically possible. Is we have called the charge conservation law. You cannot divide, suddenly turn a negative charge into positive charge. Just hypothetically, you divide. So that's a fundamental law, which is correct. Of course, we know most of the laws I'm going to totally overthrow them. Okay, not correct, but this is correct. So the charge conservation. So that means if you ignore negative charge, you subdivide, you will get the most reasonable. If you say charge conservation, so you would get two negative charge particles. So that's what Phil predict. Okay, Phil. Now my question for you: can we put a negative charged particle back into a original one?
No, because they're gonna repel.
You are not being misled by me. Okay?
Yeah, because so you're saying when you first started, the particle gets split.
Yeah,
Now
split.
you have two monopoles.
Monopoles. Yeah, monocharge.
Right.
Yeah.
So
sure.
whether it's positive or negative,
Right.
but you cannot put them back together because they're alike charges. They can't go back together.
You are citing the fundamental law, fundamental principle of the universe, actually. That's called a like charge repel, opposite charge attract. So that's Coulomb's law. You said it exactly right. So that's 1794, 1794, 95. That law.
Right.
So you basically say, what happens? We have conceptual contradictions. If any particle, you said that you carry single particles, single charge, just like this one. You carry single charge. If we hypothetically, we do not have to divide. We just say, hey, let's say part of the charge. Let's think about it. Can we say split those charge hypothetically? Okay, two positive charge, and we split have two positive halves. If you can, what happens? You cannot never combine them back to the. You cannot never form the original particle
because you created two monopoles.
So what does that mean, Mike? I want you to say.
It's like even almost like cell division. When you look at cells and they're
right,
and they divide, and
every cell can divide. Right, everything
but
we
never
know
come back. Yeah,
okay.
Multiplying themselves.
Okay. Tell me what does that mean? If you divide, if you assuming exists, however, if you divide and then you cannot put it back, what does that mean? Can this particle exist in the first place?
Under
the integrity of the particle, there's no integrity because it repels itself,
Right. So basically you say, based on Coulomb's law, you cannot combine. That means this particle cannot exist in the first place because any internal portion, fraction of the other particle is all negative. How could the negative you combine as one? Totally contradict physical laws. Okay, Mike, you got it. Phil, I hope do you agree with that one?
Yeah, I agree. It's
you agree with that. So now I have a question. Can we use gravity to combine
them? Gravity to combine the two halves. Well, it's not very strong.
You already said no. You know what? Gravity. You can say it. Say no.
I was saying no. If we already agreed that this particle cannot exist, then it still cannot exist, even if you.
Oh yeah, not even needed to discuss it further.
No, not even that.
Exactly right.
Not even that. Isn't gravity like one of the weakest forces?
That's right. If we think about it, gravity is so weak compared with combined particle force is electromagnetic force, right? The magnitude of gravity is 0.36 zeros.
Yeah, 36 magnitude.
Smaller than electromagnetic force. So you cannot. Gravity can never. You have to send to send the particles on the beach. You can never put them back, right? Because gravity is so weak. And Lulu just said, if electron itself cannot exist, we do not even need to discuss everything else. It is no longer meaningful. This is so key.
So this begs the question: if gravity is one of the weakest forces, can we classify it as a force because it's so small?
I will tell you, gravity is actually a magnetic force.
Yeah.
And now nothing is okay. So Phil agree with that. So now the question is, why gravity is so weak? Is that right, Mike?
Yeah.
So
Yeah.
if
Well,
you,
it's the
What gravity
gravitoelectric. It's the gravitoelectric energy. I have another document here that converts gravitoelectric, gravitomagnetic, magnetic field, and electric fields into energy. So they're all equivalent. They all have a energy. They all can be converted. So it's all the same thing.
Phil try to theoretically justify it. I'm gonna do it differently. I'm gonna use the experiment, demonstrate why gravity is so weak. I have 3 metal balls. They are not magnets. So now I have a line of square magnets. Okay, form a line. Okay, let's see what I'm doing. So you see how long it is, right? So now
Yeah.
I want to tell you the experiment about from a magnetism to gravity. Okay, magnetism is a very strong force. So I'm gonna. I hope you can see this one, right?
Yeah.
Attract it. Okay, so now I'm gonna use this one to attract this one. Oh. So I can attract 2 of 3 balls, right?
Right.
No problem,
Yeah.
right? Okay. This question is specific for Phil, okay? Since the gravity is in your lane. So now what I'm gonna do is I'm gonna folding this cubic magnets. I'm gonna folding them. Did you see after folding,
Right.
the center
Yeah.
of gravity is lower, right?
Hmm.
So now I'm folding again. I can folding keep more, right? But I just want to make sense. So after I folding, now you tell me, Phil, how many balls I can attract them.
You can attract.
I would say all of
I
them.
think you can attract more balls because you have a greater surface area. So
Well, the field's
yeah, that's a good
compressed.
question.
The field is compressed, and the magnetic field, when it's compressed, it becomes stronger, wouldn't it? So I would say it can pick up all those balls the way you have.
That's one answer.
I agree.
Okay.
Yeah, I would say the same thing, but I don't. I did not calculate anything in my head, but I guess you can.
I would say the other thing too is when he folded it up, if you look at it from the end, it's got a larger surface area compared to having a single row of magnets, the long, right?
The poles are
Yeah.
closer.
The poles
Yeah,
are closer
the
together.
distance plays a role. So the magnetic field adds up. It's more concentrated. It's a better density. That's a better density. That's what the word I was looking for.
It's a higher density of magnetic field.
Yeah.
Okay. So Phil, you agree with Mike and Lulu, right?
Yeah.
Okay. Let's see what happens.
We're
Whoa.
we're all wrong.
It canceled itself out.
Yeah, you canceled the magnet. Yeah.
Mike, you are so smart. You should not fall this trap.
Yeah,
I got fooled on that one.
yeah, we all got fooled.
Almost have not have a real one, not be fooled by that. I was on Pat Bad David's show. He was so quick. Before I asked Terrence Howard, I said, "Hey, tell me which one, how many ball I can put up." The host, right? Pat Bad David. of course, all three. Just like Mike said today, so quick. Okay.
Yeah, because this is exactly what I wanted to do to move my stuff out of my apartment. I knew that you can cancel magnets, and I need to cancel my magnets before packing my equipment, you know. So I knew you could cancel magnets.
So,
But
did you see the relationship between magnets and gravity? So people say, hey, I fold twice. What if you fold millions of times, like Earth? Fold millions. Do you get higher magnetic force or you get a lower magnetic force?
yeah,
Lower.
Neutralized. So that's why entire Earth is magnets. Way small. The whole Earth cannot attract this one up. Oh, yeah. Oh, no, it's already neutralized. Okay. So I already neutralized. I have to say,
You have to open it up.
I have to open up to that one. No
So
gravity.
what about if you do 2 layers, not 4? What happens if it's just 2 layers?
Oh, that's 2 layers. You so you mean okay? Oh yeah, sure.
Like if you like that.
Yes. She wanted to know if 2 layers cancel.
cut the
Yeah,
field.
it cancels
It
too.
still cancels that. Okay.
It cancels too. However,
Yeah.
if you on the other side, the local effect will be high, right? Yeah, it will cancel too. Yeah, that's good. That's good. She basically trying to say, if I just 2 cancel them, if I put 4, cancel even more, right?
Okay.
But if I have millions of cancel each other, what happens? So that's from the Earth. The Earth is so huge. But the force Earth can pull force. I can use I use magnets to pull them out. Not even a difficulty. And the Earth, you take the entire Earth to pull the one sand together. But I can use the magnets to pull them right away.
Wow.
so that means if magnets is the same thing as gravity, so that means you can cancel gravity as well.
Yes. That's what gravity was canceled. Is magnetism being canceled?
Yeah, exactly.
So small. It's 10 to the 36 power less than magnetic force. Okay, I see the lights. I can see the smile. I see. Okay, if you think this one, so you know what happens. So now I'm going to ask you. I hope you can see my screen, right?
Yep.
Mm-hmm.
Yep.
All the standard model particles has 3. You can summarize as 3 types, either positive, negative, or neutral. I believe I convinced all of you negative or positive charge particle cannot exist. Am I right?
Yeah.
Mike, do you agree?
Yeah, I would say.
Okay. So now my question is that possible we have a neutral particle?
What? Sorry, I have a what?
A
Have
neutral
a
particle?
neutral particle does not carry electric charge.
I would say yes.
No.
Yeah.
No.
No.
That would just be 0. It would be.
No,
I
you
mean,
need
it would be
you need a negative and positive one to create a neutral one.
like neutrons. Neutrons have a
Neutron is a proton and an electron.
Okay, so still neutral to 0.
Have to think about this one.
Right.
So it's the same thing. Same thing with photon, but I can't say what a photon is. It's trade secret.
Right.
Well,
A photon, I think it has 3 different measurements, not just
well,
one.
I guess there would be a neutral if you did the magnet experiment that you just showed us. That would cancel it.
Mike is so smart, so-called neutral particle made by charged magnet particle cancellation each other, right? However, you do not have but if magnets made a neutral particle, magnets carry magnetic pole, right? Polarity. So it's not really neutral. Neutral particle does not have a magnet. You can, if you say neutral, you means you have no electric charge, you have no magnetic charge, right? So
it's a cancellation of charge.
So the cancellation charge, that's what we normally say is a neutral. is a cancellation charge. But individually, at the fundamental level, we cannot have particles purely neutral.
It
The
doesn't
problem
exist.
is we can subdivide the neutral. However,
Right.
we can never combine them. They do not have a combined force.
Right.
So
Yeah.
what that means, you cannot have a visible size a particle is neutral, because if every single part of them are neutral, they cannot never combine together, right? So they cannot form any meaningful particles. And so you know the neutrinos, so-called neutrino. Actually, we measured neutrino has a oscillation. They measured neutrino can oscillate. You know what can oscillate? You have to have a mass, and you have to have a force, right? Elastic force, have to interact with the field. So that means having elastic force. So that's why you can oscillate. Which means, go ahead.
Sorry to cut you off. So a neutrino, why would you call it a neutrino?
The people create a name called a neutrino, assuming it's have no electric charge, no magnetic charge. However, experiment measured neutrino not only oscillating itself means you have charge, and also they measured neutrino has a magnetic moment made by magnets. That's just using cancellation magnets.
Right.
So it exists in the magnetic field. The neutrino could only exist in the magnetic field then.
Yes, neutrino interact with the magnetic field. That's what they find. The oscillation is interact with the field. So that means you can interact with the field. So of course you have to have magnetic features, right?
Right. It has to be there. It has to be there to exist.
If you guys get this one. So now my question is, if monocharged particle cannot exist, I mean electron, proton, and also neutral particle, proton, neutron, neutrino cannot exist. So what particle can only exist?
The magnetic field.
Okay, so Mike, I know you have so many magnetic experiments. You put like a Bushman's experiment. Okay. Can magnets be subdivided without changing its physical property?
No. The second you cut a magnet and split it into two magnets,
yes,
you get a positive, negative, positive, negative.
Yeah, so it doesn't change its properties.
You still maintain the physical properties.
Right. Yeah. Positive, negative.
And can be
single.
Subdivided infinitely.
Right.
Yeah.
You can constantly keep cutting it. You always have positive and negative. Always.
This is the only particle can exist. And this is the particle form the medium of, so we're talking about photon. I do not believe a photon or all the false carrier particle exists at all. The so-called photon is. So this is infinitesimal magnets. When you cut infinitesimal, I call the muons. Okay, universal particles, muon. So these particles are so small, it form oceans of a magnetic medium, just like ether. So so-called ether field, it's basically infinitesimal magnets, just like a water molecule form ocean water, right? So those infinitesimal magnets form the magnetic medium. You go ahead, Mike.
So the magnetic properties that you're talking about is the fabric of the ether. That is the medium.
Exactly. If ether does not have a magnetic property, how can ether's motion, ether's vibrations, oscillation, right?
Right. Like 0-point energy. There's an oscillation.
Right. Where comes that energy? And also, why a medium does not have a magnetic feature? Why it create an electromagnetic wave?
Right.
And
that's what light is. Light is a ripple. It's a vibration of the medium of the called electron. I call it magnetic medium or muon medium, made by infinitesimal muon.
So I did try at some point to write a simulator to represent an atom, and I use the standard classical physics, and it doesn't work. The atom was not stable. You know,
Right.
I did try it, so it doesn't work. So I would be interested to write a simulator using your mathematics to represent an atom. You know what I mean? The quarks and everything like that. And because I'm really interested to represent an atom at that nanoscale.
Yes. So what if you do trust in yourself, trust your logic, trust yourself, you will be agreed with me. The only physical particle can exist in the universe is a magnetic particle. So that's how much wrong with quantum mechanics standard model of physics, of particle physics. It includes every single particles possible, except excluded or absent of a real particle, magnetic particle.
Right. Are you able to represent the spin of electrons and the permeability of materials and all that?
Very good question. Very good questions. About the quantum spin. You know, the problem with quantum mechanics is it defines the fundamental elementary particle is single charge, or called mono charge. Mike called it was a monopole, right? What did you call the single charge?
Monopole. Yeah, monopole.
Monopole. If you say mono charge or monopole, what happens? So that means the particle, if the particle is a monopole, it does not have internal direction, right?
Right.
But that's the problem. We find that every electron has a magnetic moment.
Yeah.
Electron has an axis, has a north and south. So how to explain the property of internal axis?
Right.
You know what quantum mechanics created another parameter called quantum speed.
Yeah. Yeah, they just invent these terminology like spin, color charge, but it has no real representation. You know what I mean?
Yeah, they come up with all these names, and they say they find a new particle, but meanwhile, I think you're muted. Oh, I can't hear you, Doctor. Oh,
Sorry.
there we go.
Okay, so Mike, so why they create a spin? Because with quantum spin, say half spin up and spin down. Basically, they try to assign a monopole with a magnetic axis.
Right.
Spin up, if I rotate 100 spin down, they're always opposite. You know why Phil, why when we're talking about the spin, when you have a pair of electrons, they always say, hey, you have a pair of electrons come out born from the girl. When it spin up, the other one has to spin down.
Yeah.
Phil, do you know why?
Well, because they're deflected different direction in a magnetic field.
Right. That's the only way they can stay
Opposite
together.
the pole attract.
That's right.
Yeah.
That's right. So the north one has to have the north facing up, and the other one has the north facing down.
What happens if
They
not?
keep them together.
And rotate.
Yeah, that creates the orbit. That creates the orbit of the spin.
Creates that vortex with the magnetic field.
Yes,
So if you have the magnetic field and like this, like let's say this is my north and this is the south and this is the south and this is the north, it's going to chase each other and it's going to continuously, rotate.
That's what a magnetic toroidal field or you said a vortex, right? So that's because magnetic field, you have a magnetic field line from top to bottom is looped in.
Mm-hmm.
That's the loop form this toroidal shape and form the vortex, and so that's create all the motions, rotating motions. Oh my goodness!
Doctor, based on everything that you've told us tonight, you're basically saying the magnetic field, or what we're talking about, is perpetual.
Oh, magnetic field is not perpetual. Okay, so any magnet, right? It will have the effect, have this called form this line. You know what does these lines represent for? Called field. You are asking something deeper, which no physics theory ever can explain what the field is. So I'm explaining to you what a field is. A magnet has north and south. However, how magnets work is through a medium. The medium made by smaller ion particles form an ocean of this magnetic field, right? The liquid, the fluids.
Right.
So basically, if you have a magnet here, and the other magnet source north, south, north, so that means all these patterns, the field line, is formed because of existing magnetic source and interact with the magnetic medium, and all the magnetic medium, so north, south, so they aligned to form a like elastic solid structure, but however has toroidal shape. You do not need, when you say perpetual, means it has to natural in motion, right? I'm talking about not necessary in single one, you're not necessary in motion. You have a ion field, lots of smaller magnets, and then the ion field one by one, top one, so form this field. This field can be static. But one thing I have to say, under this model, magnetic field, magnetic charge are conservative. If what you mean perpetual, conservative means it cannot be born, cannot be created, cannot be destroyed.
Right.
Yeah, if that's what you mean, that means eternally.
But they're you got many charges in space, and they're interacting with each other. So in a way, they are kind of perpetual if it's different charges interacting.
Yes, if you have a multiple interaction, you create a motion. So that's where all the stars, you see stars. Star motion is what? Explosion, right? Explosion create magnets in motion and disturbance the magnetic medium. So that's create the light. So to answer Lulu's questions is photon. Photon is the motion of magnetic particles in a medium. So create a medium of vibration, and the vibrating wave interact with our retinas. So vibration, and we see the light. So basically, a photon is called a ripple, or called an oscillation and the propagation of moving, vibrating magnets.
Now, a quick question for you, pertaining to the sun. Okay, it's sending these vibrations of photons.
Yeah.
They say in outer space,
you
cannot see the sun. You cannot see it. The only time you can see the sun is when you're on the Earth and the photons react to the atmosphere of the planet, allows us to see the photon.
The so-called photon is a vibration. It has to be vibration propagates through sun's magnetic field vibrate and interact and the Earth's magnet vibrating. So
that's why you see the light.
The wrong concept is photon is traveling from the sun after 8 minutes at the speed of light hit our eyes.
Yeah, that's false.
If that one, we're all going to be blind.
I think that's instantaneous.
Oh,
it'd be instantaneous.
You are talking about the speed. If speed, if a vibration is a wave problem, wave propagation, right? Speed.
Right.
But in this case, is the particles next to your eyes vibrating, induced by the sun's explosion, magnetic motion?
Right.
And magnetic motion is an oscillation. The oscillation is local vibration. Vibration locally. However, the medium itself is magnetic, means it's elastic. So it can propagate. So local.
Yeah, it's like
this is great. You have so many visuals.
It's like a star. A star. We can see a star, but what are the probabilities of photon randomly emitted by the star reaches the retina of our eyes, So
Yeah.
the same principle.
I use this one to demonstrate how vibration, how light wave propagates. If you look at this one, I forgot, this one, every single thing, what do you call it?
I can't even remember the name of it.
Right, I could not remember the name of it.
I have one of those.
Oh, you have this one, right?
I have one.
You can make different shapes, right?
Yeah.
And every single beam is only move vertically, right? Now, I try to say how the wave moves. If okay, let me see if I can demonstrate this one to you.
Yeah, we can see it just fine.
This one, right? So is there anything I can put? So if I put some, I hope if I slide something inside here, okay.
Right.
So these are waves, right? I hope you can see. So what happens if I rotate this one?
Oh, it's carrying It's carrying the wave, like it's roll. Yeah. Okay.
Okay, I think Mike, at least you see that one, right? Did you see the wave vibration can really propagate, right?
Right.
Yeah. So that's what every single particles in the medium actually is vibrated around a static point, just like this one. They don't understand. However, the wave can propagate in the medium. So the medium will push this wave forward. So eventually they push them out.
Now, that being said, so when that wave is emanating from the sun in space, and say it hits an object on the way down, it's going to alter that wave or deflect it. Yeah. So what I'm saying is, if the wave is coming from the sun, and say something's in the way, those photons are going to hit that object. Are they going to cause a deflection of the wave in a different direction?
Oh, sure. Whenever you have an object that blocks the wave, you know what happens? Because the medium is cover everything, right? If I have an object here, medium is just like a water. You put in the water, so medium, of course, they're gonna, deflect in other direction, and then can come back together too, right?
Oh, yeah. So
that's what we see called mass bending the light.
Right.
The light is a medium, just in the water wave, right? Water wave. If you can't block, then go to the side.
Oh,
you'll see that.
You know what? That just rings a bell. They were saying the only thing that can bend light is a black hole. Well, what is a black hole? Right?
I have tried to talk about a black hole, about antimatter, about dark energy, dark matter, but that may be not for today. You don't need to think about it. They don't exist. Yeah. So deflection.
That's because of there's time dilation as well. There's gravity and time dilation. So both effects are gonna curve the light in the black hole.
Guys, I'm just gonna step away for a minute. I'll be right back.
Okay. Yeah. So I'm gonna wait for you for a more important experiment. So
don't they detect if the light bends? It means that there's a heavy mass object that they can't see when it's not like what they expect, like a denser object when the light starts to shift, and that they can't detect it. When the light bends, so it means that there's an object that's somewhere that is pulling that light towards it, right?
That's reasonable if you consider instead of a gravity pull them.
Mm-hmm.
You just say the object in the medium, say a sun, let's say a star in the middle block those lights, right? So what happens? Those lights go through around them, coming back that way. So if you see band, you can assuming objects in the way. Yeah. I think that conclusion is correct. But the interpretation is, you have a huge magnetic force bending them. That's not true.
What do you think about dark matter, Dr. Yu? Do you think there's any dark matter, or there's
no?
Because for me, it's a plugin that they use to compensate for the failures of the general relativity.
Yes, you are right. I believe so. That's the failure of general relativity. So they based on that field equation, find the singularity represent a black hole. No, that's not physical in real world. That does not exist.
Yeah. So the same thing with the gravitational lensing in galaxies. According to the galactic rotation curve, they find the mass of the galaxy to be something, and according to the lensing, they find the mass to be different. So they find two different masses using two different methods to find the mass of the galaxy. So it doesn't work.
Right. If you know all those equations, if you really know how to use it, you will find that they are garbages.
Yeah.
They made up those results. Okay. They do not have an ability. They only make up stories. They do not have the technology, technical understanding to make that work.
They don't want to admit they're wrong, so they keep using it because they don't want to admit that it's all wrong,
Right. They don't want to run. So they made up. They said, relativity principle, slow down the time dilations or something, right? So
yeah,
it's totally misinterpreted a natural phenomena. I use a weird story. So I'm waiting for when Mike coming back. I want to answer about the light. White light has to be a vibration wave. It's not a particle, because I wanted to demonstrate to Lulu actually. So since she mentioned about the photon, right? That's one of the things I have to discount it. Why photon particle does not exist? So that's why. And after I did that one, and gradually I found, oh my goodness, if photon does not exist, photon is really the ripples of this medium, ether medium. So I said, particle smaller than photon must be the particle made up of this medium, right? So that's what my focus on. What particles made of this medium, and then eventually I find that that's only one single particle can possible. Magnetic
but
particle.
do you think we can travel faster than C?
Of course. You are talking about the light. I believe you earlier you said about light is the limit of speed limit of the universe, something, right? That's what the physics claim. That's totally without having no knowledge about what a light is and what a particle is, and how to define the velocity. Of course. Okay, Mike, you're back.
Yeah, I'm back.
You have not losing too much important things with this guy. Okay, I wanted to demonstrate actually the first thing I discovered is the photon cannot be particle. It has to be a wave. One thing, do I have my laser pointer? Okay, so if you can just leave this one, so you can see my screen, right?
Yeah.
You can see the arrow, right?
Right.
I just say, hey, this arrow is just like laser pointer. Okay, I can use a laser pointer to create this light, right? And now let me ask you. The laser pointer only two little small batteries, right? Yeah, laser pointer. So when I showing on the screen, can you see the laser pointer sitting in the audience? Of course you can see. Now I say, can every single audience can see the laser pointer? Can you see that one? Okay, I think I got
it. Laser pointers, would that be a point source?
Okay.
Point source.
Mike, and
Yeah.
so can you see the laser pointer, blue point?
Yeah.
Okay. So now my question for you, if everybody sitting in the auditorium, NASA, that's my first lecture on this one, say, it's about 500 seats, in NASA's auditorium. I ask, say,
Right.
can you all see them? They all see. I pointed to the people see the corner. Can you see them? Of course we can see. I said, imagine I only have 2 batteries put on this laser pointer. I said, how many or how much particles it can generate it. So everybody in the auditorium can see them at the same time. It has to be infinite number because you have to occupy every single photon particle can occupy every single space in the auditorium so that everybody can see in the same time.
Right.
I said, is that possible? A 2 battery can generate infinite. I said, if you take the roof off, take the wall away, half of the universe can see the photon. I said, do we have enough photon particles for everybody to see? Answer is no, you cannot generate just a single flight, and you generate an infinite number of photon particles occupy entire half universe. They said that's impossible. So then I said, okay, what is the alternative? What if I tell you the universe is already filled with those oceans of the fluids?
Right.
Just like a water.
You're just creating the vibration to make them visible.
Vibration propagation. I just create the vibration, use a light source.
Right.
And because the medium is a magnetic medium, magnetic medium form elasticity. Okay.
Right.
All the elasticity formed by magnetic bonds. Okay. So that means when your local vibration propagates,
right,
it's like a water through a pebble in the pond, and the ripple.
Right. The ripple effect.
That's the analogy. Say everybody can see at the same time, because we already have particles that fill up the universe. So space is not an empty. Does that make sense to you, Mike?
I have something to show also.
Okay. I have a more convincing experiment to show the light too. Okay. Now I want to see your demonstration.
Okay. It's not an official experiment. It needs to be done in vacuum. But this is the Cavendish experiment with light. So we'll see what happens. But it's not official because it's not in vacuum again. So it needs to be redone in vacuum.
So you're focusing a light on the one side and you're causing it to move.
You are telling me light rotating this one?
Yeah, you can see the light attracts the rod.
Yeah.
Oh, it's attracting it.
Yeah.
Oh, light attraction. Oh yeah, sure. Yes.
Wow, that's cool.
That's
No,
cool.
it stays
That's
there.
very cool. That's very cool. That's how we use laser light to control lots of experiments to direct to moving the particles in the vacuum chamber. Yes.
Right.
Light.
Yeah.
You know why light can attract. Can you explain this one to me?
Well, it's vibrating the electromagnetic medium. So if that's the case, then it's going to pull anything that is a solid object towards it.
Yeah.
Well,
Because the vibration
I mean,
create a vacuum. Basically, create an instantaneous vacuum there.
Right.
So
And
that's
now-
why it cannot move. It just follow you. Yeah. Because
Right.
whenever
Yeah.
you go, you create an instantaneous vacuum, lower pressure.
Well,
fluid.
mathematically, I explained it as energy differential again, because you have a high density, high concentration of energy, low concentration of energy, so that creates a force, and the rod is attracted to the light because of the energy differential. But that's a mathematical explanation, but that's not a physical explanation.
From now on, you listen to your own mind. Use the physical. It's all about the physical. When you super fast vibration, you create a vacuum, lower pressure field next to you.
Right. Oh yeah, you're canceling it out. Yeah.
So you're creating a gravity well, in a sense.
Yeah. Cancellation.
0 point. Yeah. Void. It creates like a void.
Yeah.
It is energy well. Yeah. It's energy well. So that's why vibrating. So it's trapped there. Yeah. Wow. So now I'm going to demonstrate another decisive to demonstrate why light cannot be a particle. Let me see if I have a better background here. My goodness. Okay. I try to find yeah. Okay. I hope this background good enough for me. Okay. So I have
I predict it's going to be about refraction.
Are you able to see through this one? Okay, yeah, I can see through it, right? Yeah, you can see through. So I have 3 transparent films.
Right.
Okay, I know you guys know what kind of film I'm using, right? Okay, so if I stack them all together, so individually you can see through them, right?
Right.
If I stack them, you can see through them, right? Okay.
To a point. Yeah.
I'm sorry. Yeah. Okay. So now my question is, if I stack 3 of them, you can see. Okay. If I stack 3 of them. Oh, okay. Sorry about it. If I stack
that's the polarity.
Polarizer. You can see through them. So that means. So what happens if I take one away? Put the 2 together. Are you able to see through them?
When they're not together, yeah.
Yeah, when they're together,
that's the polarity.
Becomes, yeah.
That I can't see through both.
Yeah,
you can see through them, right? Okay.
No.
Yeah, that's the
But
polarity.
you see what I did is I just rotate. If I rotate back.
Oh, right. Now I see it. Yeah. I see that. Yeah.
Yeah, that's the polarity.
What does that mean? That surprised everybody. Because we are intuitively assuming light is a particle. So if a particle can go through 3 of them, so particles of course should go through 2 of them.
Right.
But
if one's off, oh right. So if it's a different
totally blocked. So that means the particle view of light is not true. If it's true, particle can go through the gaps in the 3 of them. Why particle cannot go through 2 of them, right? Okay.
Right.
One further. This is the hardest one, okay? I want to ask Lulu. Give me explain. So now I have 2 of them total blocked. Right? I'm not going to change this one. But I have another transparent film in my hand. I'm going to slide in this one in without changing this hand. Tell me, are you able to see through?
Yeah.
Or not to see through?
You'll be able to see
You will be
through.
able to, yeah.
You guys are right. But you know what? I always demonstrate, first I will demonstrate how people get it wrong, okay? So this is blocked. I put it here. Blocked. Put it here.
Wouldn't you have to like line up the gradient of the medium?
Gradient medium. So I said, okay, I'm going to slide in the middle. Okay, did you see? I'm gonna slide in the middle. Are you see through or is it getting even darker?
It's getting darker.
Yeah, I can't
Now
see.
I rotate this way, getting to the middle. Still darker, right?
Still darker.
Yeah.
I put it in the back as for false, doesn't matter. So I usually first ask them, so can see through or not. If they say cannot see through, I will show them right first. But if they can see through it, I will show them wrong first. And then what happens? I put this one in the middle, 45 degrees. I hope you can see through the top part, but bottom block.
Yeah, I could see a little bit.
So you're changing the frequency in a way, aren't you?
No, that's the polarity.
No, the polarity, because the light is polarized. So what that means, light is a vibration. Vibration has a plane.
Right.
So we call it the polarized plane. So if this one blocks that plane, if I put it in the middle, block that plane.
Right.
90 degrees. So no matter vertical, horizontal, no light can go through them, right? So that's why you cannot see the light. Right. But if I put 45 degrees means what? The first two, see?
Yeah, you can see partially, yeah.
Yeah, see, it's partial. Yeah. I have to somehow, so this way, right? And then the polarizer has a certain angle.
Right.
Yeah. Okay. Are you able to see now?
Yeah.
Partially. Yep.
Only 45 degrees. When the 45 degree means you divided the two slides.
Right.
Each slide has a 45 degrees. Means your projection, you still have a partial of a projection can go through that. So the vibration plane, you can partial light go through it. If it's completely 90 degrees, you cannot go. What this means, the reason it surprises people is we always use intuition light as a particle to explain this one. But if you use this one, light cannot be particle, right? It's 100% wave, because this property, polarized property, so only works with have a polarized plane. That's what a vibration plane is. Right. Oh my goodness!
Would it look like this for like two of them?
Right. Yeah. That's
two of them.
Yeah, that's two of them. You involved one they normally call the electrical wave, another is a magnetic wave, right? For 90 degrees to each other. Yeah.
Okay, so pertaining to, say, electricity going around the wire.
Oh my goodness, where's my? I'm gonna try to find out the electricity slide. I hope okay. So.
That's great. You got visuals. That's awesome.
Did you see two models?
Yeah.
One in the right, I put a flawed. So that's what the current theory says. Electron is a physical particle traveling in solid wire at fraction of speed of light. I said that's impossible. And especially, we demonstrated electronegative charge particle cannot exist. Everything's made by magnets. Can magnets traveling at that speed? People, I believe BurnEye made some kind of measurement, right? Any particles, magnetic particles in any fluids or anything moving so slow, like a garden snake, right? So there's no way magnetic particle can travel. So then what is electricity then? If you look at the blue, green line, that's the Yuan theorem model. Electricity is vibration, oscillation. And the particle, every single particle in the wire are magnetic particles, right? Well, what happens? Magnetic particles oscillate. The magnetic medium propagates magnetic form elasticity, right? So the particles propagates along the line, so it's all oscillation. That's what electricity is. Any questions?
I know there was some experiment. I need to refresh my memory, but somebody proved that what you said, but in a different way. But I need to refresh my memory. But I'll find it if I just maybe I can send you an email.
Okay.
About when I find the video back, but I need to refresh my memory on that.
Okay. So I just want to explain how the oscillation generated. All generated. So this is a handcraft generator.
Right.
All generators are either have a permanent magnets and rotating rotors with coil, or rotating magnets with a fixed coils. You always have a relative motion. So when you I hope you can see the lights, right?
Yeah.
Okay. So all the lights is generated through what? Coil, which coil made by magnetic particles. Every single atoms are magnetic particles, right? In the coil.
Right.
When you rotate a coil in magnetic field, what happens to those atoms?
You start vibrating.
Right? Yeah, the north vibrating. Yeah, the oscillation vibrating. So that vibration goes through the medium. That's the atomic atoms combined, just like an elastic medium, right? So that oscillation propagates. That's what the electricity is. The oscillation created always relative motion between magnets and permanent magnet field and the coils. Relative motion.
So that changes the definition of ampere. The coulombs per second.
Yes.
That changes the definition.
Coulomb, yeah, I got that was almost 80 years ago. I'm a co-host on radio talk show. Audience listened and then wrote back to the host, say, "Hey, Doctor, you said it's not true." He said, "We already measured. What is it? I forgot. It's 1.2 million electrons jumping. Those electrons go through the cross section or something. Some number. So we already measured. There's so many of the electrons passing the cross section." Okay, so then I have to write to him. I said, "How do you know? How do you calculate? How do you find out? You know what happened?
What's the proof?
Electroscope, right? The oscillation measure the waves, right? The wave cycles.
Right.
What is the waves from? From oscillation, right?
Yeah, it's right in front of you. It's right in front of you. Yeah. It's a wave. Magnetic wave.
I hope I made some sense to you guys.
Yes. Yeah, you did. It was awesome. That was
But
really
I have a little question. Is the permeability of a material changes the propagation of the wave?
What kind of material?
The permeability, the relative permeability.
Okay, sure. Yeah, sure. Yeah.
The relative, all materials, they all have a different relative permeability.
Of course. So that's why
you
are not changing wave. You're changing the propagation speed. Am I right?
Yeah, exactly. Yeah. So different material have different propagation speed.
Sure. So that's why if light, I believe light goes through diamond, only like 40% of the speed of light. Reduce by that much. Sure.
Okay. Here's a question for you.
Okay.
The old Tesla experiment where he made It's like a pendulum, and you would have two magnets together, and they're being held back. And what happens is he put a little candle under one of the magnets. So what happens is when the magnet heats up, it loses its magnetism, and the other one is able to separate from the other magnet. Why is it the heat makes the magnet weaker?
Oh, sure. You know, magnetic is strongest once they're aligned.
Right.
When them align them, right? That's the strongest.
Right.
What heat do? Make them random oscillate.
Okay.
So no longer strong like them. So use magnetic strength will be, if you align them, strength is higher, increase. So two magnets. If this one, strength higher. But if you two magnets doing this one, it's a neutral, right?
Right.
So now you said that if I have a heat make them oscillate, right? Can no longer be perfectly crystal aligned them. So that's why magnetic field is weaker. If they collapse them, if they completely collapse, somebody apply the heat, right? Use hammer to hit them. Oh my goodness! Magnetic field goes zero, lost it.
Really?
You know what happens? They form the neutral particles.
Ah, interesting.
Yeah. So I should have been aware it was a tricky question, your first question. So next time you're not gonna have me so easily.
I know you are smart man. Okay, catching your food is not easy, right? But you know what? You are not. Let me tell you, all these things I did hundreds of times. You know, I'm NASA. I'm doing a lot of outreach. Yeah, almost everybody follow. Don't blame yourself. You are not the only one.
Yeah.
I'm sorry. I wanted to hop in quickly while I could. I apologize. I couldn't join for the stream tonight, but I've been listening whenever I could turn my phone on. It died at the beach today, but I will rewatch this in full. I promise, Dr. Yu, and we will do another one together very soon.
Right. Yeah,
you missed a good show, Bernie.
You
I know, it kills my soul. I'm like, oh, just the way it was meant to be today. I guess so. I didn't interrupt too much.
You just dodged Dr. Yu's. He just brainstormed us, you know.
Yeah.
So you just dodged his brainstorm. So
actually,
I missed out.
Bernie does not miss anything. Bernie listened to me hour and a half speech, right, in person at the Tesla conference. So
and I'm going to be re-listening to this one, and we're going to be doing a one-on-one, and we got to talk more on the phone.
Sure.
I love talking to you as well.
If you have
stay
any
tuned.
questions.
Also, stay tuned. I'll get my cylindrical magnet next week, and I'll be in San Diego in 2 weeks. So I'll do even better experiments over there with professional labs.
Well, Phil, I might have to come visit you in San Diego with my girlfriend Carmen when she comes down, because it'll be the same time, and I promised Carmen I'd take her to San Diego.
Nice, and we'll beach party on July 4th if you're there too.
Yeah, I'll be back in Canada by then, but hey, you never know. Maybe I'll be in Florida with Dr. Yu by then.
Yeah, you're all over the place, man.
It is what it is, but thank you so much, Dr. Yu, and I'll let you guys get back to the last 15 minutes, and we'll see you all again soon.
Okay.
The only one not traveling is Mike. You know?
Yeah. Thanks a lot.
Okay. I'm not gonna go any further, but I'm gonna show you this video, and you tell me how universe was formed from space dust. Okay. So this astronaut, we are sort of friends, interact many occasions, and this is Stanley Love.
Scientists understood where stars come from, but not how planets grow from the disk of gas and dust. The answer was discovered by accident aboard the International Space Station. Astronaut Don Pettit was experimenting with grains of sugar and salt in the weightlessness of space. Stanley Love was watching for mission control when Pettit stumbled onto the process of how planets form from cosmic dust.
Well, one of Don's Saturday morning science projects was to take the bags that we store drinks in, and he put other stuff in it, like salt and sugar, and there was one bag that he just left the coffee powder in. Then he inflated the bags, and with these particles in them, noticed that the particles would just clump up immediately. They make a little dust bunny.
We'll be spending some time watching that.
I said, Don, this is incredible. You've just solved a 40-year-old problem in planetary science.
Astronaut Pettit had discovered something big. In the zero gravity of space, particles of dust don't float apart, they clump together. This is how mighty planets are made from cosmic dust.
Cool.
I hope it makes sense to you, right, Mike?
Yep.
They are. Go ahead.
So will all those particles in the bag there basically have a magnetic charge on all of them, and they all clump together.
You know the fallacy about the electron? We said the electron the same called a monocharge, carry negative charge. If all the particles carry negative charge electron, what they should repel, right?
That's right. But they all come together.
All come together. I have video show all electron never repel. They may be temporarily, you see, eventually they all attract.
Oh yeah, there was an experiment with some fluid where they noticed the electron
Right.
being attracted together. So I'll find that experiment and I'll forward it to you.
Oh, okay, wonderful. And I want to explain what's going on inside of the.
Right.
You see, if even you have a like pole, if it repel initially, eventually end up they all attract. Okay, you might see
that makes total sense.
Interact with magnets. Yes.
Right. Back in the early or late 1890s, Tesla, when he was making his spark gaps, he would take two magnets and focus it where the gap of the spark is.
Right.
And he called it quenching the spark gap by pushing two like poles of the magnetic field towards each other with the gap in the middle of the magnets to focus and compress the spark gap. He called it quenching the spark gap.
Yes, I believe last time we discussed what is it called two electrodes, right? How they create the sparks, right? Yeah,
right.
That's because in the space between them, you know, the two electrodes represent the north and south, different polarities.
Right.
And the space filled with muon particles is a magnetic particle. So close enough, right? So they form a magnetic line. Just like this experiment called a cathode ray experiment.
Here we can
see the electrons being deflected by the magnet. The cathode ray moves upward. If we reverse the magnet, we would predict that the beam would be deflected in the opposite direction. And we observe that the beam is deflected downward.
Okay. That's all I have for today. If you guys are interested in nuclear physics, quantum physics, relativity, oh my goodness. You are interested. So that's a different topic. Okay. I can dark matter, dark energy, gravity. I give you
go ahead,
evidence
Lulu.
on gravity.
We have to cut it off in about 4 minutes because I want to be able to
No, I was
this.
only raising my hand because he said if you're interested, so I was just raising my hand. That's all. Yeah.
Well, I'll be watching the show again because we like to thank Dr. Yu. He did an awesome show. Little applause for Dr. Yu. Really amazing. He really kind of has fixed my ideas and kind of got me in the right direction. So I'm going to definitely have to watch this show again tomorrow. So it's going to help me out with my projects and hopefully
You're gonna have to sleep on it.
yeah, it's one of those shows you'll just have to watch over and over and over again to absorb all the
Absolutely.
info. So we'll have this in the archives. As you know, everybody, we do our show every Friday night at 9 o'clock Eastern, 6 o'clock Pacific. And I'd like to thank Lulu, Philip, and of course, Dr. Yu. You're always welcome on our show. I'll be talking to BurnEye, and hopefully we'll be able to get you on the show again in the next few weeks whenever you're available, or if you got something new you want to share with us, hey, drop us a line, and we'll definitely have you on. Everybody stay on after we go off so we can just have a little chit chat after. Everybody, thanks a lot for tuning in. We'll see everybody next Friday at 9 o'clock Eastern. Take care.
Thank you, Dr. Yu. Next time I'll drink 2 or 3 coffee before the show.
Okay. Take care, everybody.
All right. Cheers.
Thank you.